So we've been talking about many different things so far in chapter 1, starting with dividing our multiple digit numbers. We're going to go down through and do about 2 to 3 example problems for each subject that we've been covering so far in chapter 1. So like I said, if you don't have a notebook with you, I would go grab one just so you can copy down these example problems. So I already have mine written up here on the board, but I would like you to copy it down and do the problem with me as we go. All right? So first set, estimate, then find the quotient. Write the remainder, if any, with an R. So this time we're going to write the remainder with an R. We have 965 divided by 17. The first thing we have to do is estimate. I prefer, like we talked about before, use those compatible numbers. Don't always estimate with the way that you were taught to, if it's 5 or more, you round up. If it's 4 or less, you stay the same. So to me, what looks like is going to work best is if we take 965 and make that 1,000 and divide that by 17, we could make that 20. So then we have 1,000 divided by 20. 20 to put it into 100 is going to be 5. And we can subtract here. And that gives us 0. We bring down that last 0. So our estimate's going to be somewhere around 50. All right? Now we're going to go through and do the actual dividing. So now we're looking at 965 divided by 17. So if I come over here, first I'm looking at 17, that can't go into 9. So I'm going to put a 0 there to hold the place. Now I'm looking at 96 divided by 17. Not quite sure what I can multiply 17 by, so I'm going to come over here to the side. Let's try 17 times 3. 3 times 7 is 21. 3 times 1 is 3, plus 2 is 5. We can go higher than that. Let's try 17 times 6. 6 times 7 is 42. 6 times 1 is 6. Plus 4 is 10. Oh, I went a little bit too high. So let's try 17 times 5. 7 times 5 is 35. 5 times 1 is 5. Plus 3 is 8. So we'll go with the 5. And then we have 96 minus 85. 6 minus 5 is 1. 9 minus 8 is 1. And then we have to bring down the 5. Now, lucky for us, we did 17 times 6, and that got us to 102. Can't get much closer than that to 115. So we'll do times 6 is 102. And then we subtract again. 5 minus 2 is 3. 1 minus 0 is 1. 1 minus 1 is 0. So our quotient is 56R13. Now, and this is our final answer. Now, sometimes it's going to ask you to put the remainder as a fraction. And if you have to do that, you take your remainder and you put it over your divisor. And then if you can simplify it, you would. But 13/17, it can't be simplified anymore. So if I was going to write it as a fraction, it would be 56 and 13/17. Okay? Now we're going to come over here to the second division problem. This one's a little bit of a bigger number, but that's okay. So we have 4,380 divided by 29. First thing is to estimate. I'm going to say we should take 4,380 and make that 4,000. And then we'll divide 4,000. I think we should take 29. Instead of rounding it up to 30 like we normally would if we were following our rounding rules, I'm going to make it 20 because that makes it easier to divide out in my head. 20 goes into 40 two times. Minus 40 is 0, and then I have to bring down a 0. and bring down another 0. So our estimate is going to be somewhere around 200. That means our quotient will be somewhere around 200. Now we're going to look at our actual division problem. Starting with 29 into 43. So let's see, can we multiply 29 times 2? 9 times 2 is 18. 2 times 2 is 4, plus 1 is 5. Nope, too high. So it can only go in once. Minus 29. We can't take 9 away from 3, so we have to regroup. 13 minus 9 is 4. 3 minus 2 is 1. Then we have to bring down the 8. So now I'm looking for a number that I can multiply by 29 to get close to 148. Let's do 29 times, let's do 5. 9 times 5 is 45. 5 times 2 is 10. 11, 12, 13, 14. 145. Woo, we're close. So we'll put a 5 above the 8. Minus 145. 8 minus 5 is 3. 4 minus 4 is 0. 1 minus 1 is 0. And then we have to bring down that last 0. 29 goes into 30. It's only going to go in one time. Minus 29. Regrouping. 10 minus 9 is 1. And, oops, 3 has to be a 2. 2 minus 2 is 0. So, if we're writing the remainder with an R, it's going to be 151 R1, remainder 1. If we were writing it as a fraction, so here's my quotient. If I was writing the quotient as a fraction, 151 and 1/29. Two different ways to write that. All right, so there's a little bit of review for how to divide multiple digit numbers. Now I'm going to clear my board so we can go down to our next set of examples. Now we're looking at prime factorization. Now I'm going to do this so we only see these numbers. So if you don't remember prime factorization, when we're talking about factors, we're talking about the numbers that we can multiply together to make our bigger numbers. And when we're talking about prime factorization, it means we're looking to get our factor tree down to the smallest prime numbers possible. So for 21, this is pretty easy. Think what times what equals 21? 7 times 3 equals 21. And look at that, we're done. Those are both prime numbers. They can't get any simpler. So our prime factorization for 21 is 2 times 3. Not 2, oh my goodness, what am I thinking? 7 times 3. Mrs. Bauer. 7 times 3. Now we're looking at 130. This is a bigger number. It ends with a 0, so that means it can be divided by a 2, it can be divided by 5. I'm going to try dividing by 5. Think what times 5 is 130. So I'll put a 5 over there, and I'm actually going to come over here and do a little bit of division. 5 goes into 13 2 times, minus 10 equals 3. Bring down the 0. 5 goes into 36 times. So it's 5 and 26. 5 is a prime number already, so we can pull it down. 26, it's an even number, so we can at least divide it by 2. And that would be 2 and 13. So now, we're at our total prime factorization for 130 as well. It's going to be, we should probably list them in order from least to greatest, because that's what it asked us before. 2 times 5 times 13. And I'm going to go over here and fix this one and put it in order from least to greatest too. 3 times 7. here's our little refresher for prime factorization. I'm going to clear this off and move it down for our next. Next, we're looking at least common multiple. Now, there's a difference between factors and multiples. Multiples, we're dealing with multiplication. So what are the numbers that I can multiply, or what are my multiplication facts for 5 and 20? And then I'm going to look for the smallest or the least number that they have in common. So for 5 and 20, we're going to list out the multiples. So we have 5, 10, 15, 20, 25, 30, and I'll stop there. 20, we have 20, 40, 60, 80, 100, and I'll stop there. Let's see if we have any common multiples. I see 20, and that's all I'm seeing right now. So the least common multiple for 5 and 20 is 20. Now remember, it's not always going to be the case that it'll be one of the two numbers, or multiplying the two numbers together isn't always going to give you the least common multiple either. So you want to make sure you're listing them out. I know it takes a couple seconds, but that's okay. That's what we have to do. Now let's look at 6 and 15. 6, 15. Listing out our multiples. So you have to think, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. All right, then we have 15. 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, and I'm going to stop there because I noticed I already have a multiple that's common between the two, and it's 30. So our least common multiple is 30 for 6 and 15. Now the next thing I'm going to do is we're going to take a look at a word problem. Now you're not going to have time to copy down the words for the word problem, but I'm going to show it to you so I can show you what you need to pay close attention to when you're reading the word problems. Because that seems to be what's the most confusing when it comes to what we've been doing so far. Alright, so this problem says, pencils are sold in packages of 10, and erasers are sold in packages of 6. What is the least number of pencils and erasers you can buy so that there's one pencil for each eraser with none left over? All right? So now, this word least is going to tell us we're using the least common multiple. Least. When you see that in a problem, what is the least number? You need to find the least common multiple. So, our numbers that we're dealing with are 10 and 6. So let's list out our multiples for 10 and 6. 10, 20, 30, 40, 50, 60. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. Common multiples, I see 30 and 30. So that means, and you also need to pay attention to what the question is asking. It wants to know the least numbers of pencils and erasers. So in total, we're going to buy 30 pencils and 30 erasers. Notice that it's not asking how many packages of each that we need to buy. If it was asking how many packages we needed to buy, then for the packages of pencils that are in sets of 10, we would buy 3 of those to get to 30. And the packages of erasers that are sold in sets of 6, we would buy 5. But that's not what it's asking. It just wants to know, flat out, how many pencils do I need? How many erasers do I need? And it's 30 of each. All right. Now we're going to move on to our next examples.